Hello everyone. Today we are going to look at the derivation of the deviation caused by a prism. And here is our diagram. As we're drawing this diagram, we simply created this normal at point P and still created a normal at point Q. Okay? Now we are going to look at a ray of light that is moving from air to glass. And this ray of light is making an angle of incidence I at point P. By the law of refraction, so we expect this ray to be refracted at a certain angle, which we call R1. That angle will be measured from the ray towards the normal. Since this ray is moving from air, that is vacuum, to glass, the ray has to be refracted towards the normal. So as it is refracted at an angle of refraction R1, it continues through glass and meets point Q. As it meets point Q, this R2 will now act as our angle of incidence in that medium, which is glass. That angle we are calling it R2. And since the ray has to propagate back to air, it will be refracted now, this time around away from the normal. Why? Now we are moving from glass back to air. Glass is denser than the refractive index of glass is greater than that of air. So we expect this ray to be moving away from this normal as it is being refracted. So we measured this angle as E. That is the emergent angle, the angle of emergency. Now, since we are deriving the deviation caused by a prism, we have seen that this is the angle of incidence as a ray is moving from vacuum to glass. That is I. Then we said R1 will be the angle of refraction. The ray continues to point Q. Now R2 will be the angle of incidence in that medium. Then E will be the angle of refraction as the ray moves back to the vacuum. So we are deriving the deviation caused by a glass prism. Now let us look at this point P. Point P. Without this glass, this ray would have taken that path. Is that clear? Without the glass prism, the ray would have taken that path. So the angle between the refracted ray and the would-be path of that ray is what we are calling deviation 1. The angle of deviation 1 at point P. So as this ray continues to point Q, we can see that it is still refracted back to the vacuum. Without this, still this ray would have taken that path without the glass prism. So the angle between the refracted ray and the would be the path of the ray becomes the second angle of deviation. So we have deviation 1 at point P and deviation 2 at point Q. So where these two rays meet, we are forming another angle which we are calling D. D1 denotes the deviation caused at point P. Then D2 denotes the deviation caused at point Q. Then DCD will be the total deviation as the ray moves from vacuum to a glass prism and back to the vacuum. So we are deriving the deviation caused by that glass prism. Let us derive it together. D1, can you express D1 in terms of R1 and I first? Yes, we can do that. So deviation 1 at point P. So let us say at P, at point P, this point P, deviation caused there will be equal to I minus R1. I minus R1. Where does it come from? Let us go back to point P. We are looking for this angle of deviation in D1 in terms of R1 and I. So mathematically, the whole of this angle I is equal to the whole of the angle when you add D1 to R1. Which property is that? These are two corresponding what? Corresponding angles. Angle I will be equal to D1 added to R1. I will be equal to the deviation, angle of deviation caused at P, plus the angle of refraction at P. Since these two are corresponding, the whole of this angle is equal to the whole of this angle. So that's why we are saying at point P, deviation 1, that angle of deviation, equals to I minus R. Where did this come from? Remember we said that I equals to D1 when you add it to R1. Okay? Since those two angles are corresponding at point P. Now when you make D1 the subject, D1 will be I minus R1. And this is the expression we have here. We continue. At Q, at point Q, deviation 2 will be equal to E minus R2. Deviation 2 is equal to E minus R2. Why are we saying that deviation 2 is equal to E minus R2? At point Q, like we saw at point P, the whole of this angle E equals to, when you add D2 to R2, D2 added to R2 is equal to the angle E. These two angles still are corresponding angles. E equals to D2 plus R2. Now when you happen to make D2 the subject of this formula, then we shall have D2 equals to the angle of emergency E minus R2. So we can call this one equation 1, call this one equation 2. So having those two equations, D1 and D2, remember we said D1 is the deviation caused at point P. Then D2 will be the deviation caused at point Q. And D will be the total deviation for that ray that is moving from vacuum, glass, and back to vacuum. We are trying to derive the deviation of the ray caused by that glass prism. So D is the total deviation. Still from mathematics, we all know that these two interior angles add up to one what? One exterior. So the two interior angles we have are D1 and D2. The one exterior angle we have here is D. So to get the deviation caused, the total deviation caused, so total deviation caused will be D equals to D1 plus D2. Total deviation is equal to deviation at P plus the deviation at Q. Two interior angles add up to one exterior angle. From the diagram we can see it that these two interior angles, the D1 and the D2, add up to one exterior, which is the D. Two interior angles add up to one exterior, which is the D. So we have D is equal to D1 plus D2. Continue. So our deviation equals to, remember from our equation 1, D1 is I minus R1. Now we are adding it to D2, which is E minus R2. Deviation at P plus deviation at Q. Now by simplifying this, our D will be equal to I plus E, then minus R1 plus R2. I1 plus IE. I1 is the angle of incidence as the ray is moving from vacuum to glass. Then E is the angle of emergence as the ray is moving from glass back to a vacuum at point Q. R1 is the angle of refraction at point P. Then R2 is the angle of incidence as the ray is moving from glass to air. So our D now simplifies to the total deviation caused. D simplifies to I plus E, then minus A, where R1 added to R2 is always equal to the angle of the prism. When you happen to look at this diagram of ours, when you simply add R1 to R2, this will act as our two interior angles that will add up to one what? One exterior. This angle of the prism is the same as this what? This angle. So A is the angle of the prism is equal to this very angle here. So when you happen to add R1 plus R2, you simply get this A, since these two are interior angles that will add up to one what? One exterior angle. So whenever we see R1 added to R2, simply replace that with A, where R1 plus R2 is A, and A is the angle of the prism. So our deviation D caused by the prism is equal to I plus E minus A. This will be the expression for the deviation caused by a glass prism, where I is the angle of incidence as the ray is moving from vacuum to glass. This E is the angle of emergence as the ray is emerging from glass back to a vacuum. And A is the angle of the prism. So thank you for watching. Let us meet again when we are deriving the deviation caused by a small angled glass prism and the minimum deviation caused by a glass prism.